Perpendicular bisectors, circumcenters, equidistant to the vertices. Angle bisectors in centers equal to the side. You've got the medians crossing at the centroid, 2/3 the distance to the other side. Altitudes crossing at the other center. Perpendicular bisectors, circumcenters, equidistant to the vertices. Angle bisectors in centers equal to the side. You've got the medians crossing at the centroid, 2/3 the distance to the other side. Altitudes crossing at the other center.
Well, welcome everyone to Chapter 6 in our Big Ideas curriculum. We're talking here about relationships within triangles, 6 sections that we'll be going through, and just kind of like that song was talking about, perpendicular bisectors what we're talking about today, and there's definitely different relationships, as we will see. That kind of video was just a little preview of what are things to come here in this chapter. So as we get into our first section, perpendicular and angle bisectors, we're going to be using perpendicular bisectors to find measures, using angle bisectors also to find measures in distance relationships, and even writing equations of perpendicular bisectors. We're going to go back to doing some linear equations again of perpendicular lines. First, let's do a little cartoon of the day. So here Superman had a little laundry mishap. This would be the last time Superman washed his suit with his cape. It's not a word. See, as his cape is red and his suit is blue, so red and blue make purple. All right, going into our theorems now. So whenever you see the theorems in the notes, you should be studying these theorems. These are the things that you need to know and need to study. I can go over them. I go over them kind of quickly, but you want to go over them in depth. You want to definitely know. This is the important stuff to know when it says theorems. This is a perpendicular bisector theorem, and the converse is just it in reverse. So back and forth. So basically what the perpendicular bisector theorem is saying is if you have what's in black here originally, and basically you have this line CP is a perpendicular bisector of this segment AB. So it's got the perpendicular mark, it's got the congruent marks here because bisector means it's right in the middle. So P is the midpoint between A and B. Then what we can conclude is that if you have a C out here, so if you have a point somewhere, anywhere on this line, on this perpendicular bisector line, that point to each end point here from A and B are going to be also congruent or also equal to each other. So CA is equal to CB. Those are going to be equal to each other. And what we do really make here, if you notice, we have 2 triangles now that we've created, and you can kind of be able to understand why these are congruent even just from our last chapter. We have a side and an angle here with the right angles, and then also a shared side from C to P. So side, angle, side, that means that these 2 triangles would be congruent. As long as we make these here, draw this line here to this line, definitely those sides would have to be congruent because of side, angle, side even. The converse just means you have it in reverse. If you're shown this out here where the point D is there and these 2 are congruent, then we can conclude what we have a situation here is that, this is a perpendicular bisector that D would lie on. That means that point D is going to lie on the perpendicular bisector. Even though you don't see it here, it's not actually on the line. But we can conclude that this perpendicular bisector will actually go through point D. All right, so again, read through this, study this, more in depth. Let's go on to our extra practice. Okay, so here on page 168, our extra practice 1 through 3, wanting to find the indicated measure. Right here, A, B, E, G, and SU. It says explain your reasoning. We'll do that for the first 2. We may not do it for the third one, but we'll definitely explain our reasoning on these first 2. For this one, we can see that we have a perpendicular bisector with BC. So you have your BC here. The sides here are both 6, so we know that this point is at least the midpoint. It is also perpendicular with this line, so this line is the perpendicular bisector. than of that. So that way means we can conclude that A, which is on the perpendicular bisector, is the equal distant from B as it is to C. So if AC is 9, then we know that A to B is also 9. That's got to be 9. There's our explanation that line AD is perpendicular bisector of segment BC, so AC is equal to AB. On EG, what we have is kind of it in reverse, more of the converse on this one. We can see that what we have here is that we do have this line going through. It is perpendicular, and since F, which is on this line, is equal distant as it is to G as it is to E, so they're both 7 there, that means that we know that this F has to lie on the perpendicular bisector. That means that this has to be a perpendicular bisector between G and E, making both of these sides equal to 3. So if this side is 3, then HE is 3. So that means that the whole segment here, which is what we're trying to find, is 3 plus 3, segment addition, which would just be 6. So this is 3 here, and so EG would be 6. And again, the explanation was explain this one. It's because of EF equals GF, as we can see there. Then, so because that's equal, then HF, that line HF, is the perpendicular bisector of EG. And from that, we can conclude that these both sides are the same. And now for 3, we're looking for SU. So SU is just this little section right in here. So what we do have, again, if you look at these, we have 10 on both of the sides, so it's more like number 2, where we can conclude that these two are congruent down here, that R must be on the perpendicular bisector of ST, because R to S and R to T are the same number 10. And so these two are equal, which means we can set these two equal to each other to make an equation. So those two are congruent. And the one that we're actually trying to figure out, now you're going to realize we're trying to find SU. So what are we really trying to solve in this one? We just want to know what would this side be. Well, it's going to be the same as the other side, but we can focus on that's what we're trying to figure out. Once we find x, we'll need to plug it into this 2 times x plus 2. It'll give us the same thing as it would over there with 3 times x. So here's we're going to set up our equation. 2x plus 2 equals 3x. And then we're just going to subtract 2x from both sides to get the x over there on the right side. So 2 is equal to x. So if x is 2, then we can plug 2 inside here. So it's going to be 2 times 2 plus 2, and that gives us 4 plus 2, which then SU tells us it's 6. So we would have got the same thing here with 3 times 2, that's also 6. All right, let's move on to our next. Okay, so this next section is going to be writing an equation of a perpendicular bisector, and I just wanted to kind of look at this one really quick, as it's a little bit different than the one we'll actually be looking at in the extra practice. This one shows us a segment, PQ, and it shows us a line in red here going right through here, the M, and what it tells you here is it says write an equation of the perpendicular bisector of the segment with endpoints P and Q. So this is the perpendicular bisector. It says write an equation of the perpendicular bisector of the segment with endpoints that has that. And so that's what we're trying to figure out. We're trying to write that equation. As you can see, what we're going to end up doing, we need to really locate what M is. So the red part is actually already the answer. They kind of showed us the answer. The blue part was the problem. The red part is the answer. So the first thing to do is to locate the midpoint here. So we have our midpoint is M, and we figure that out using the midpoint formula with the points here with P and Q. And that's what they're doing there to get 1, 2. So now we know that's what our midpoint is. And then we can write an equation from that. We would need to figure out, well, what's the slope of PQ? We could figure that out by rise over run. And the perpendicular slope is always opposite and reciprocal for this. And so we would use that slope. So that's what we're doing next. They're finding the slope of PQ. That's a negative 1/3. So the slope that we have that we're going to write will be 3, so 3x. And also, where is that going to go through the y-axis? Well, we don't know yet, because even though, yeah, we could see it here, but that's really the answer already. We wouldn't know this yet. We would then need to take one of these points, P and Q, and plug it in. We can then plug it into y equals mx plus b and solve for b. So we can plug in one point. Doesn't matter which one they choose here. You have the They chose the actual midpoint, really. You can actually, now that's the point we're supposed to choose, sorry, not P and Q. We need to choose the midpoint because that's going to be on our perpendicular bisector, of course. I was getting too confused with the other 2 points. We use those points to find the slope. We use those points to find the midpoint. But when we actually get to writing the equation with y equals mx plus b, we use the opposite reciprocal slope for m, which is 3, and the midpoint, the 1, 2, going in for x and y. And then we can solve for b. And once we know that b is -1, we can then write that equation, and that's what that is right there. Okay, so here for number 4, we're finding the equation of the perpendicular bisector of AB. So again, we just have AB, and it shows us a line, but we can just really focus on the segment. So again, just like we saw, the first thing we need to figure out is where the midpoint between A and B is going to be. So we need to identify points A and B. So we can see A is right down here, so it's 0 for x, -2 for y, and B is over here at 2, 2. So there's our ordered pairs for A and B. We use those with the midpoint formula. So we want to now find the midpoint. And so we do that by adding the x's together, divided by 2, so kind of creating a new ordered pair here. So our x now is going to be the 2 x's here added together, divided by 2, and then the 2 y's together as well, adding these 2 together, and then dividing by 2 as well. So this is going to be 2 over 2, and this will end up being 0 over 2, which will then become 1 for 2 over 2, and 0 here for 0 over 2. So our midpoint is the ordered pair 1, 0. So we can go ahead and plot that right there on the x-axis. That's the midpoint. The perpendicular bisector is going to go through that point, kind of this direction. So now we need to figure out what's our perpendicular slope that we have from here. So we need to identify what is this slope. So even just doing rise over run for this slope, if the rise is 2, the run is 1. And so that's 2 over 1, or just 2, positive 2. So the slope here, and that's what we're doing, rise over run, we can see 4 over 2 if we want to go from A to B, or you can go A to this midpoint like I did, but 4 over 2 is going to be reduced down to 2 as well. So either way you do it, you should get a 2 for the slope. So now we'd want to figure out, okay, what's the opposite reciprocal slope? That would be our perpendicular slope. So the perpendicular slope, the opposite is going to be negative, and the reciprocal of 2 is a 1/2. So we know our m, the m of our equation, is going to be a -1/2. Now, there's 2 ways we actually can write the equation at this point. Now that we have the slope and we have a point that's going to be on that line, we want to use this point, 1, 0. What we could do is we could do the what's called the point slope formula, which would be this right here, y minus y1 equals m times x minus x1. That should look familiar from Algebra 1. Or we could just plug it into the y equals mx plus b like I just showed you on that last screen. And I think that's the way we'll do it on this one. And you can always use this if you want to. Your ordered pair would be the x1 and the y1. That would be your 1 and your 0. And then your m is there. And then you just got to simplify it from there. You would just clean it up to a y equals mx plus b equation. But if we just go off of our y equals mx plus b, this is the other way, like I just showed you, we can just plug everything in we know. We don't know the b though. So we could plug in the y is 0, and the m we know is going to be a -1/2 for the one we got to use, and the x is a 1. So you plug all that in, and that's what we get. And now we're going to say, okay, 1 times the -1/2 is still -1/2. So it'd be 0 equals -1/2 plus b. So we have to add 1/2 to both sides. And so we bring the 1/2 over here. 0 and 1/2 make 1/2. And so b is just a 1/2. So now we can write our equation because we have m is here at -1/2. That's the perpendicular slope. And our b is also 1/2. So our equation for the perpendicular bisector is going to be y equals the -1/2 x plus 1/2. There's your mx plus b equation. Alright, so I'm going to have you try one just like this. We're going to do number 8 on here. And we're going to do that on the bottom of page 166. So I want you to try this one. It says write an equation. This is just number 8. Write an equation of the perpendicular bisector of the segment with endpoints -1, -5, and 3, -1. So what I want you to do is I want you to pause the video and try to do this problem on your own and see if you can write the y = mx plus b equation of the perpendicular bisector with these two endpoints. So just go through what we just went through on number 4. It's the same thing. It's just instead of it showing us on the graph, we actually have the points here. These are the 2 points that you have to use. So you got to find the midpoint between these two first. Use that midpoint when you're writing your equation. Get the perpendicular slope, so you need to figure out the slope between those 2 points as well. You can just subtract the y's over subtracting the x's for that. All right, so go ahead and pause the video and then check your answer in a minute. All right, so hopefully you're now ready to check your answer. So here, let's go through this. So we're finding the midpoint first between these 2 points. So we're going to add the x numbers together, divide by 2. It's -1 plus 3 divided by 2. Add the y's together, divide by 2. So it's -5 plus a -1 divided by 2. And so the x's now will become a 2 over 2, and the y's become -6 over 2. Then you keep simplifying to get the actual ordered pair here. So 2 over 2 is 1, and -6 over 2 is a -3. Now that's the x and the y that you're going to use when you're writing your equation. So make sure that's why I highlighted those, x and y. That point now is a special point. We have to use that one for our writing equation of the perpendicular bisector. We now need to figure out what's the slope of these 2 points. So we go back to our 2 ordered pairs again up in the problem and find the slope of the 2 ordered pairs. So I'm just going to subtract the y's over subtracting the x's. So my y's just got to be consistent, start with the same point both times. So I'm going to start with the first ordered pair. So my y there's -5 minus -1. So it makes a double negative, so you can see I've changed that to positive. And then for the x's on the bottom, -1 goes first, and then -3. And so on the top now, we're going to end up having -4. On the bottom, we also have -4. So anything over itself will always equal +1. So -4 over -4 is just a 1. Our slope here is 1. And so we now need to use the slope that we have to use for our equation is the perpendicular slope of that, which is opposite and reciprocal. Well, there is no reciprocal for 1. If you flip 1 upside down, you still have 1. But we do have an opposite of 1. So we're going to say our perpendicular slope then, we're going to use the perpendicular slope of -1. So we'll use that -1 and our midpoint to write our equation using the y = mx plus b. So we plug everything in. Our y of that point is -3, m will be -1, and the x of that point is +1. And we just don't know the b, that's what we're solving for. So -1 times 1 is still -1. And then we just add 1 to both sides to solve for b. And so now b is going to be -3 plus 1, which would be -2. So now that we know that our m is -1 and our b is -2, we can write our equation as this: y equals -x, that's a -1 slope there, -2 for the b in the back. And that's it. That's our answer. That's what we're trying to get. All right, let's move on to our next part. Actually, before we get to our next part, let's do a little joke of the day. What do you get from a pampered cow? What do you get from a pampered cow? So a cow that is pampered, taken very good care of, given everything the cow wants in life. Well, of course, if you do that, you will get spoiled milk. Ugh, spoiled milk. That's awful. It smells and reeks. Hate spoiled milk. Okay, we're going to get into 2 more theorems, and again, really it is one theorem, but just the reverse, the theorem, and it's in reverse. Again, study these theorems. These are what you really need to know. The perpendicular bisector theorem, and now the angle bisector theorem is here in front of us, 6.3. And it's very similar to the perpendicular bisector theorem, except it's now dealing with angles. We're bisecting an angle here, so we have an angle bisector happening. And basically what it says, if a point lies on the bisector of an angle, that would be point D out here, then it is equidistant from the 2 sides of the triangle. Now you got to remember that the distance from D to this side of this angle here has to be at a perpendicular fashion, because you can be putting D over here or BD over here. the distance is always going to be perpendicular. So whenever you're doing a distance to some line, some point to some line, it will always be in a perpendicular way. So that forms right triangles then inside here. And that's what it's saying here. If AD bisects, right here, if AD bisects this angle, and DB is perpendicular to AB, and DC is perpendicular to AC, which means that these are perpendicular. That means that's a distance right there. Then those are distances are equal. DB is equal to DC. As long as you see the perpendiculars right there, and we have a bisector in here, then we know that these two segments are going to be the same and equal. And that's what we can also conclude this in reverse. So if we know this, if we see that these two lines are perpendicular and they're equal, so if a point is in the interior of an angle and is equal distance from the sides of the angle, then it lies on the bisector. So that's what we could see. If we have the perpendicular are there and DB is equal to DC, then we know that AD bisects this angle. Then we know that this is a bisector of this angle. That's what we can know. Alright, again, you want to make sure you understand this. So keep reading it, keep studying it, keep looking at it till you understand it. That's what you want to do for all of these theorems that we do in geometry. Alright, back on page 168, 5 to 7, we're now going to use that angle bisector theorem, just like we did with the perpendicular bisector theorem. And so it says, we're finding the indicated measure, explain your reasoning. And I'm not going to write down the explain your reasoning on this one, but you just know that you would need to do that on the assignment for sure. The explaining the reasoning is just explaining through those theorems of why you're concluding what you're concluding. So measure of angle CAB, so CAB is here. We're trying to find that measure. We're already told that this is 20 degrees. What we're told also is that D to C is equal to D to B, and they are perpendicular to these two rays over here. So what we have is that converse situation. So what we can conclude, and basically here's what you'd explain here, because DC is perpendicular to AC and DB is perpendicular to AB, and DC is congruent or equal to DB, then that means that D lies on the angle bisector of CAB. That means that AC, or we can say AD, is the angle bisector of CAB. So if that's true, then if this is an angle bisector, that means these two angles are the same, they are congruent, which means this side is also 20. And that means that we're going to add those up with angle addition, because we're adding it for both CAB for both angles. So that's 40 degrees for CAB. And then for number 6, we're looking for DC. So side DC, or the length of DC, which should be right here. And what we have on this one, we can see that we have an angle bisector, that AD is the angle bisector, because they're both 30, so this is definitely an angle bisector here of the angle of CAB. And we also see that D to B is perpendicular to AB, and D to C is also perpendicular to DC. So those are distances. So what we can conclude then is that these two distances are going to be the same. So if this is 5, then that's 5 also over there. Those are equal or congruent. And so DC is equal to 5. And then for number 7, we're looking for DB, so that would be this segment here. It's the 3x plus 1. And our situation, again, is that we have an angle bisector with the marks here. The diagram marks off the angle bisector. So here's your angle again, CAB or BAC. And it is bisected because of these marks in here. This AD is definitely that angle bisector. DB is perpendicular to this side. DC is perpendicular to this side, so that means that these two are equal, they are congruent. And so we can set up our equation with these two being equal to each other. So 3x plus 1 will equal 5x minus 1. Let's solve for x by first subtracting 3x from both sides, and now it will be 1 is equal to 2x minus 1. Add 1 then to both sides, and so now it's going to be 2 equals 2x. And so if 2 equals 2x, then we know that x equals 1. If we divide by 2, or 2 times 1 is going to give us still 2. So if x equals 1, we're going to plug that back into, and it really wouldn't matter which one you did it. You're not going to get it wrong if you pick the wrong one, but we really should go back to db right here, the 3x plus 1. So if I go back to that specific expression, 3 times x, 3 times 1 now is x plus 1. And so now I'm just going to do 3 times 1 is 3. 3 plus 1 will give us 4. That's what dB is going to be. It would be the same thing for this one over here. All right, so that concludes our 6.1 lesson. And you're ready for the assignment, and then I'll see you back on 6.2.